As we have seen, MATPLOTLIB is very versatile. However, generating a composite plot to show different sections of a data frame often requires quite some lines of code. To overcome this verbosity, many libraries provide more expressive ways to generate specialized plots using MATPLOTLIB under the hood. One of such libraries is pandas. Here we show that in a single line we can select a cross-section of the multi-index data frame on waste generation from the Eurostat database, drop the non-EU countries, and directly call the hist function of the data frame. The extra arguments we need to pass are the list of columns we want to plot and the array of the corresponding axis objects. Without much effort, we have obtained a composite plot with the histogram for each year in a separate subplot. It is straightforward to overlay the histogram for another material on the same plot. To make the bars for plastic and glass visible while they are overlaid, we change the transparency of the bars by setting the alpha parameter to 0.5. Here is another example of a composite plot generated on one line. We select 5 categories of recyclable waste and keep only the EU countries in the data frame. Then we group by waste category and sum over the countries. This way we obtain the total amount of waste produced in the EU for 5 materials and the various years. When we call the function pi, we obtain pie charts for each year, showing the percentage of the total for each waste category. The arguments that we need to pass are also in this case the column names and the array of axis objects. We can also specify the format of the percentages that label the slices of the pie chart. For the next example, we're going to use the Eurostat dataset on waste treatment. We select the same 5 categories of recyclable waste, keep only the EU countries in the data frame, select a year, and use group by to loop over the different materials. For each material, we plot the amount of burnt waste versus the recycled waste. Since we are plotting on the same axis in a loop, a different color from the top 10 palette is automatically assigned to each material. Seaborn is a library for making statistical graphics. It is typically imported using the shorthand SNS, as we do here. In this lecture, we're going to show only a Seaborn tool to plot categorical data. However, as shown in this gallery, Seaborn can be used for many purposes, for instance to examine relationships between multiple variables, estimate linear regression models, and to visualize univariate or bivariate distributions. To make the most out of Seaborn, the data frame should present each variable in a column and each observation in a row. To manipulate our waste treatment dataset into this particular organization, we have to go through several steps. First, we turn the column names into year indexes using stack. Second, we turn index level 1 into a column names. Third, we turn the waste and year indexes into columns. We define the makeDF function, which performs these steps and also allows us to select a list of years. The tidy data frame is suitable to be plotted using the lmplot function, which creates a composite scatter plot and optionally also plots the corresponding regression model fits. The first 2 arguments are the columns corresponding to the x and y values. The second argument is the data frame, which we generate using the makeDF function. The third argument is the column of labels that we want to use to color the data, in this case the waste categories. The fourth argument is the column of labels that we want to use to map the data frame onto the axis objects. Here we want to plot the data for different years in separate subplots. The grid of subplots has a number of columns determined by the parameter callWrap. To customize the plot, we modify the object returned by lmplot. Here is how to label the axis, set the axis limits, and the distance between the subplots. This video concludes our series of lectures on the MATPLOTLIB library.